Good morning. So today we can study the topic pressure bulb. Before going to pressure bulb, we can see what is an isobar. An isobar is a curve joining the points of equal stress intensity. Or in other words, we can say isobar is a contour of equal stress. It has a shape of an electrical bulb or an onion. The curved surface is symmetrical about the vertical axis passing through the load point. Here we can see this is the curved surface, and here we can see the ground surface. This is the ground surface. A load Q is acting downward, and due to this load there will be stresses developed in the ground. The stresses will be different according to the distance from the load acting point. So here we are trying to find out the points which have the same stress intensity. That means there will be stress intensity of 0.1 Q, that is 10% of the applied load, or there will be stress intensity of 0.2 Q or stress intensity of 0.3 Q. Like that, we are finding the points which have the same intensity, and we are trying to pick out these points and draw a curve which is known as isobar. So how can we find the stresses at different points? The stresses can be found out using the Boussinesq equation. Boussinesq equation is sigma z equal to IB into Q divided by Z square. Here sigma z is the vertical stress at a depth z, and IB is the Boussinesq influence coefficient, which is equal to 3 divided by 2 pi into 1 plus r by z whole square whole raised to 5 by 2. And Q is the vertical load acting downward. This is the vertical load which is acting in the downward direction. And small r is the horizontal distance from the load point. That is, this is the load point. From here, at a particular distance, at a particular horizontal distance, what will be the stress that we are going to find out. So r is the horizontal distance from the point load, and z is the vertical distance from the point load. That is, from Q at what depth is the value z indicates. Okay, so here we are first trying to draw the isobar of stress intensity 0.1 Q. So we can write sigma z equal to 0.1 Q. So here in this equation, sigma z equal to 0.1 Q, which is equal to IB into Q divided by Z square. Here IB is 3 divided by 2 pi into 1 plus r by z whole square whole raised to 5 by 2. So IB equal to, we can write from both sides, Q will cancel, and IB will be equal to 0.1 z square. So from this equation, that is, this is the equation for finding the stress intensity of 0.1 Q. So for 0.2 Q stress intensity, equation will be different. Same way, 0.3 Q intensity, stress intensity equation will be different. So here we are using this equation for finding out the stress intensity of 0.1 Q. So here we can say, first for this equation IB equal to 0.1 z square, for this equation we are using different z values and finding out the different IB values. So starting with z equal to 0.25, we will get an IB value of 0.00265, and 0.5 z value 0.5, we will get IB value 0.25. For Z value 0.75, we will get IB value 0.05625. For Z value 1, we will get IB value 0.1. Likewise, we are getting the different at different depths what will be the IB values. So once we get the IB value, we know IB equal to 3 divided by 2 pi into 1 plus r by z whole square whole raised to 5 by 2. So from that we will get, for a particular IB value, we will get the value of r by z from that equation. So r by z value is also tabulated. Once the r by z value is obtained, we already know the depth value z, so we can find the r value also. R is the horizontal distance from the load acting point. Okay, so we are getting different values of r also. These are the different r values. So we are getting z value and r value, which means the x coordinate and y coordinate, that is r and z values are obtained. So using this r and z values, we are finding the points on the ground which have same stress intensity. So these are the points we can see here. At depth 0.25 q, we are getting a particular r value. This is the point, and next point is z equal to 0.5 and r is corresponding value, and for z equal to 0.75 we will get another r value, and for z equal to 1 we will get another r value. Likewise, we got the different points. So what is the speciality of this isobar? Once we get one side of the isobar, that is one side of the different points, the points will be same on the other side also. That means it is symmetrical about the vertical axis. So we will get a shape like this. This is a bulb like shape. It is lemniscate in nature, not a circle. So here we can see one value 2.185. All other values we took 0.25 interval, and next value, last value is 2.185. What is the specialty of 2.185? At 2.185, r value is 0. So how we got this depth z equal to 2.185? It is simple, because we are just putting the value of r equal to 0 in this equation, that is IB equal to 3 by 2 pi into 1 plus r by z whole square all raised to 5 by 2. In this equation we are putting the value of r equal to 0. So from there we will get the corresponding z value. That z value is the 2.185. So what will happen at the depth z equal to 2.25? When we use the z value 2.25, we will get the r value as negative. So 2.185 is the, here we can see 2.185 is the point where r value equal to 0. That is the maximum depth where stress intensity is 0.1 q. Okay. So similarly we can draw the curves for 0.2 q, 0.3 q, 0.4 q, like that. So all these points, that is isobars of intensity 0.2 q, 0.3 q, etc., obviously will lie within the isobar of 0.1 q. Okay. So this is isobar. Isobars are useful for determining the effect of load on the vertical stresses at various points. The zone within which the stresses have a significant effect on the settlement of structures is known as the pressure bulb. So what is the difference between a pressure bulb and isobar? Isobar is a curve joining points of equal stress intensity. Then what is pressure bulb? Pressure bulb is the zone within which the stresses have a significant effect on the settlement of structures. Okay. the zone within which stresses have a significant effect on the settlement of structures is known as the pressure bulb. It is generally assumed that an isobar of 0.1 Q forms a pressure bulb. Okay, that is why we are using 0.1 Q stress here. 0.1 Q stress intensity of isobar is usually used as a pressure bulb. The area outside the pressure bulb is assumed to have negligible stresses. Okay, thank you.